Okay, this is a cosecant graph this time. I did a very different cosecant graph because I wanted you to see something here. And it really has something to do with the period and phase shift and how it's going to look. So to do this, you're going to have to factor out that 1/2. But I also want to show you that not only in front of the x is there a 1/2, but there's this 1/2 pi. So that is going to create something very interesting here that we haven't seen. So your period here, your b value, is not just 1/2, it's actually 1/2 pi. So when you do that, it's going to be 2 pi divided by b, which is 1/2 pi. Now the pi's are going to cancel, and then you get 2 divided by 1/2, which is 2 times the reciprocal, so that ends up giving you 2 times 2, and the period is 4. This is the first time we've seen a period without a pi in it. So very, very interesting to look at for this one. If you want to go ahead and I'm going to erase this right here so we can just look at the phase shift now. So if I factor out that 1/2 pi, it actually, if you do that, it actually is 3 cosecant, and then you get the 1/2 pi factored out. Ends up being x. And then when you factor 1/2 pi out, it's actually divide pi by 1/2 pi. The pi's are going to cancel, and you multiply reciprocal, it's going to be -2. So what happens here with that being factored out is you end up with a phase shift of right 2, which kind of makes sense with our period. So this is definitely different. So our phase shift is going to be right 2. And hopefully you can see that up here. Then you factor that 1/2 pi out. That 1/2 pi cancels right here, and then when you take pi divided by 1/2 pi, you get that -2. There is no vertical shift here, so we got none there. So now, since I'm doing cosecant, I'm going to graph sine. I'm going to set up my period, so I'm going to go out 1, 2, 3, 4, and I'll put a couple marks to the right again, and I'll do 4 marks to the left, just to go ahead and look at that. So our period is 4. I don't think you're going to have to think too hard to cut this one in half. 2 and then 1, so we're counting by 1, so that makes it kind of nice. So notice you don't have any pi's on here because you actually factored out a pi, and the pi is a part of the b value, which really changes the amplitude, or changes the period and the phase shift. Okay, so then my new middle, there's no vertical shift, so it stays at the x-axis. If I was graphing sine, I would have an amplitude of 3, so I'd go up 3, 1, 2, 3, and I'd go down 3, 1, 2, 3. So sine starts in the middle. So let's take a look at this. Here's where sine usually starts, but there's a phase shift of right 2, so we're going to actually start it right here. So go ahead and put a point right there. And then it's not flipped, so we're going to go up first, and then we'll go back down, and then we'll go down 3 at here, and then back here at 6 will be in the middle, and then we'll go down 3, and then back in the middle, and then up 3, back to the middle, down 3, back to the middle. So there's my sine graph as a reference to graph cosecant. So now everywhere this crosses the x-axis, because we didn't shift it up or down, we're going to have our asymptote. So at 4 and at 6, this is going to make the asymptote equations a little different, but it's still the same. You do the same process. And I wanted to make sure I did one of these because I hadn't done one in class where the pi actually is a part of the b value. And then, so let me go ahead and get the rest of my asymptotes in here. I've got more than 2 periods graphed. It looks like I got 2.5 periods graphed, but that's kind of cool, I guess. And then those are where my asymptotes are, and then I put my hats in. Hat up, hat down, hat up, hat down, hat up. There's 2 periods, and then hat down looks like 2.5 periods, sorry. And then your asymptotes are just going to be, you just need a start asymptote, so don't change anything. So a start asymptote, you could say 0. And then plus multiples of half the period, because remember, half the period is between asymptotes. 2 sets of asymptotes create a full period, so this is just half p. P being the period, half of the period. So it's plus multiples of half the period. So let me make that plus sign a little bit better. That's going to drive me nuts. So we got 0, which is our start asymptote, plus 1/2 multiples of the period. I still can't do my plus sign. The period was 4, so half of 4 is 2, so it's just going to be 2k. And the only difference is there's no pi in it because the pi canceled out. Domain's going to be x cannot equal 2k. And then my range is going to be y is greater than or equal to 3, or y is less than or equal to -3. And there is this secant graph.